8-2 right triangle trigonometry practice solutions. Starting with 2 through 4, we are finding the sine, cosine, and tangent for theta. So if we look at number 2, we have 12, 15, and 9. The 15 is our hypotenuse since it is across from the right angle. Your theta is across from your theta is your 12, so that's your opposite, and then adjacent to it or next to it is that 9. So sine is opposite over hypotenuse. That's going to give us 12 over 15, which is 4 over 5. For cosine, we have adjacent over hypotenuse, so that's going to be 9 over 15, which simplifies to be 3 over 5. And then tangent is opposite over adjacent, so 12 over 15, 12 over 9, so that is 4 over 3. For 3, we have the triangle that have side lengths of 2, 3, and the square root of 13. So our hypotenuse is the 13, our adjacent is the 2, and the opposite is the 3. Oops. So sine opposite over hypotenuse. This is going to be 3 over the square root of 13, which then we multiply this top and the bottom by the square root of 13 to give us 3 square root 13 over 13. For cosine, we have adjacent over hypotenuse, so this is going to give us, adjacent is 2 over the square root of 13, which then simplifies to be 2 square root 13 over 13. For our tangent, we have opposite over adjacent, so that's 3 over 2. For 4, we're dealing with 4, 1, and the square root of 15. Our 4 is our hypotenuse, our 1 is our adjacent, and our square root of 15 is our opposite. So our sine is opposite over hypotenuse, so that's the square root of 15 over 4. For cosine, it's adjacent over hypotenuse, so that's going to be 1 over 4. And then our tangent is opposite over adjacent, so that's the square root of 15 over 1, which is also just the square root of 15. For 5, 6, and 7, we are using a trigonometric function to find the value of x. So we are dealing with a special right triangle here. So we have a 30, 60, 90 triangle here, which means we're going to have side lengths of 1, 2, and the square root of 3. So that 1 is going to be the smallest side length, that square root of 3 is the middle side length, and then that 2 is the longest. So from here, we are dealing with two sides that we have. We have the hypotenuse, which is the one that's x, so our hypotenuse is x, and our adjacent is the 50. So if we're working with hypotenuse and adjacent, we're working with tangent, which means we're going to use the values that we plugged in here because of our special right triangle and the values they give us. So our hypotenuse, hypotenuse and adjacent is cosine, not tangent. Okay, so let's back up here. All right, so hypotenuse and adjacent, we're working with cosine. So adjacent over hypotenuse, which means the adjacent is the 50, the hypotenuse is the x. We're also using the values we plugged in there, so the square root of 3 over 2. We are going to cross multiply with this, and we are going to have x square root 3 is equal to 100. We divide each side by the square root of 3. We rationalize that denominator, and we're left with x is equal to 100 square root 3 over 3. For 6, we have a 45, 45, 90 triangle, so we're going to have side lengths of 1, 1, and the square root of 2. So with these, that 45 degrees, we're working with our hypotenuse and our opposite. opposite, hypotenuse. So sine is opposite over hypotenuse. So this means that we're going to have x over 30 is equal to 1 over the square root of 2. We cross multiply with these, so x square root 2 is equal to 30. Then we divide each side by the square root of 2. We rationalize that denominator, so we multiply top and bottom by the square root of 2 to give us that x is equal to 30 square root 2 over 2. And then we simplify that 30 will turn into a 15, the 2 turns into a 1, so x is equal to 15 square root 2. For 7, we have a 30, 60, 90 triangle. So our smallest side length is 1, our hypotenuse is 2, our middle side length is the square root of 3. So what we're dealing with here is our what? Our adjacent and our opposite. So this one's going to work with tangent because tangent is opposite over adjacent. Our opposite is 250. Our adjacent is x. The 250 also goes with the square root of 3, and the x goes with 1. So we're going to cross multiply with these, and we're going to have 250 is equal to x square root 3. We divide each side by the square root of 3. We rationalize that denominator, so we multiply the top and the bottom by the square root of 3. And we're going to have x is equal to 250 square root 3 over 3. See what 8 says. 8 says, an escalator in a mall must lift customers to a height of 22 feet. If the angle between the escalator stairs and the ground floor is 30 degrees, what will be the length L of the escalator? For 9, it tells us that the pilot of a hot air balloon measures the angle of depression to a landing spot to be 20.5 degrees. If the pilot's altitude is 9 meters, what is the horizontal distance between the balloon and the landing spot round to the nearest meter? Let's look at what D is. With the rest of these questions, I think it's all of, no, just for 10 through 12, we are finding the values of the 6 trigonometric. Let's look back first to see what the last questions are asking us to do. It says P is a point on the terminal side of theta in standard position. Find the exact values of the 6 trigonometric functions. So for our next examples, 8 and 9, I think, hold on one second, let's go back. So we are finding for L here. Once again, we have a 30, 60, 90 triangle here that we're working with. So we're working with our hypotenuse and our adjacent. So because it's adjacent over hypotenuse, we're working with cosine. So then we have adjacent, which is the 22, over hypotenuse, which is L. And then since we're working with a 30, 60, 90 triangle, we're going to have 1 square root 3 and, 1, 2, and the square root of 3, making sure that 2 is our hypotenuse and that 1 is the smallest side length. So this is going to be set equal to 1 over 2. We are going to cross multiply with these. So L is equal to 22 times 2, which is 44. So we will most likely need a calculator with this one. So we have a triangle that looks like this. We're finding for x. So x is here. So look at what you have here. We are working with what and what to find for x. We are working opposite and adjacent. So opposite and adjacent is our tangent. So if opposite over adjacent, we're going to do tangent of 20.5 degrees is equal to opposite, which is 90, over adjacent, which is x. So we are going to multiply each side by x. This is going to be written as x tangent 20.5 is equal to 90. And then in order to get x by itself, we're going to divide each side by tangent 20.5, which this is what you're going to need your calculator for. So on my calculator, I'm going to hit that tangent button. I'm going to hit 20.5. Oh, no, sorry. I'm going to do 90 first. I'm going to clear that. I'm going to do 90, then divided by the tangent button, 20.5. Close the parentheses and hit enter, and it should give you your answer, which making sure your calculator is in degree format. So if you go to your mode, because that's what I just did this and realized it gave me a negative answer, and it's because my calculator was in radians. You want to make sure your calculator is in the mode of degrees. Then do the 90 divided by tangent 20.5. You should get 240.7159 and so on. We're rounding to the nearest meter here, so x is going to equal 241 meters. Okay. So for D, metric functions for theta. So for 10, we have side lines of 3, 5, and one that we're missing. That x is our hypotenuse. So we are going to use the Pythagorean Theorem. So 3 squared plus 5 squared is equal to c squared. 3 squared is 9. 5 squared is 25 is equal to c squared. 9 plus 25 is going to give us 34. And then we take the square root of each side here. So c is equal to the square root of 34. Remember, 34 is just 2 and 17. 17 is prime, so you're not going to get another simpler form of the square root of 34. So the 6 trigonometric functions are sine, cosine, tangent, cosecant, secant, and cotangent. Sine is opposite over hypotenuse. We said that our opposite here, we didn't say. So our opposite is the 5. The adjacent is the 3. And our hypotenuse was what we found, which is the square root of 34. So we're plugging these all in. So sine is opposite over hypotenuse. So this is going to be 5 over the square root of 34. We're going to multiply top and bottom by the square root of 34 here. And we're going to be left with 5 square root 34 over 34. Cosine is adjacent over hypotenuse. So our adjacent was 3. Our hypotenuse is the square root of 34. So again, we're going to multiply top and bottom by the square root of 34 to rationalize this denominator. And be left with 3 square root 34 all over 34. Tangent is opposite over adjacent. So opposite is 5, adjacent is 3. Your cosecant is hypotenuse over opposite. So that's going to be the square root of 34 over 5. For secant, you have hypotenuse over adjacent. So that's the square root of 34 over 3. And then cotangent is adjacent over opposite. So that's 3 over 5. So for these, sine was 5 square root 34 over 34. Cosine is 3 square root 34 over 34. Tangent is 5 over 3. Cosecant is the square root of 34 over 5. Secant is the square root of 34 over 3. And cotangent is 3 over 5. For 11, we have a triangle that has side lengths of 2 and 2 square root 10. Our opposite is what we're missing. So this is our adjacent. This is our hypotenuse. The opposite is what we're missing. So we have to find that first. So let's do 2 squared plus b squared is equal to 2 square root 10 squared. So it's going to give us 4 plus b squared is equal to 4 times 10, which is 40. So 4 plus b squared is equal to 40. We're going to subtract the 4 from each side to get b squared is equal to 36. We take the square root of each side to get that b is equal to 6. So our opposite is 6 here. Let's write all these down. Opposite is 6. Adjacent is 2. hypotenuse is 2 square root 10. All right, so our sine is opposite over hypotenuse. So that's going to be 6 over 2 square root 10. This 2 becomes a 1, this 6 becomes a 3. We rationalize this denominator, so we multiply top and bottom by the square root of 10 to give us 3 square root 10 all over 10. Our cosine is adjacent over hypotenuse, so that's going to be 2 over 2 square root 10. So this simplifies to be a 1 over 1 square root 10. We rationalize that denominator, and we end up with the square root of 10 over 10. For tangent, we have opposite over adjacent, so that's 6 over 2, which simplifies to be 3. The reciprocal of sine is cosecant, so that's CSC, so that's going to be hypotenuse over opposite. So a hypotenuse over opposite is 2 square root 10 over 6. The 2 and the 6 simplify to become 1 and 3, so it's just the square root of 10 over 3. The reciprocal of cosine is secant, so that's hypotenuse over adjacent. So that's going to be 2 square root 10 all over 2. We simplify the 2's to become 1's, so it's just the square root of 10. And then the reciprocal of tangent is cotangent, which is opposite over adjacent. This is going to give us 2 over 6, which is 1/3. Okay, so our next one that we have here is number 12. We have side lengths of 1 and 5 over 2. Our theta gives us that 1 is our opposite, the one we're missing is our adjacent, and that hypotenuse is 5 over 2. So we're going to use 1 squared plus b squared is equal to 5 over 2 squared. 1 squared is 1, plus b squared is equal to 25 over 4. We can turn that 1 into 4 over 4. It'll make things a lot easier when we go to subtract it from each side, just so that way our denominators have the same number. So this is going to give us b squared is equal to 21 over 4. So we take the square root of both sides from here, and b is equal to the square root of 21 over 2. So our opposite is 1, our adjacent is the square root of 21 over 2, and our hypotenuse is 5 over 2. Our sine, cosine, and tangent we're going to find, as well as our cosecant, our secant, and our cotangent. Alright, so these are going to take a little bit more work. I probably should erase these and put them underneath so that way I have a little bit more room to work with. Alright, so sine is opposite over hypotenuse. Remember, division is the same thing as, fractions are the same thing as division. So when we do sine, which is 1 over the 5 over 2, it's the same thing as saying 1 divided by 5 over 2. So keep, change, flip. 1 over 1 times 2 over 5 is going to give us a sine of 2/5. For our cosine, we have adjacent over hypotenuse, so that's the square root of 21 over 2 all over 5 over 2. So that's the same thing as the square root of 21 over 2 divided by 5 over 2. Keep, change, flip. We're going to have the square root of 21 over 2 times 2 over 5. Those 2's will simplify to become 1's, and we're going to just be left with the square root of 21 over 5. For tangent, we have opposite over adjacent, so that's going to be 1 over the square root of 21 over 2. So that's the same thing as 1 over 1 divided by the square root of 21 over 2. So we're going to take the reciprocal of that second fraction and multiply these two. So 1 over 1 times 2 over the square root of 21. This is going to leave us with 2 over the square root of 21. We cannot leave the radical in the denominator, so we have to rationalize these. So we're going to be left with 2 square root 21 all over 21 for our tangent. All right, so the reciprocal of sine is cosecant. Oops. Go back to the pen. There we go. So cosecant is going to be hypotenuse over opposite. So that's going to be 5 over 2 over 1. Anything over 1 is itself, so it's just 5 over 2. For the reciprocal of cosine, it's secant. So that's hypotenuse over adjacent. So it's going to be 5 over 2 divided by the square root of 21 over 2. So keep, change, flip. It's 5 over 2 times 2 over the square root of 21. The 2's simplify to become 1s, and we're going to be left with 5 over the square root of 21. We rationalize that denominator by multiplying the top and bottom by the square root of 21, and we're left with 5 square root of 21 over 21. And for our reciprocal for tangent, we have cotangent, which is going to give us adjacent over hypotenuse. So adjacent is the square root of 21 over 2 over opposite, which is 1. So it's just the square root of 21 over 2. Got to remember, sine is y over r, cosine is x over r, and our tangent is y over x. So for 18, we have to find what r is for all of these. As of right now, our x is 3, our y is 2. So we're going to use that in our Pythagorean theorem. So we're going to have 3 squared plus 2 squared is equal to r squared, or c squared, same thing. So 9 plus 4 is equal to r squared. Then 9 plus 4 is 13. So if we take the square root of both sides, r is equal to 13. So we have x is 3, y is 2, r is 13. Our sine is y over r, which is going to be 2 over the square root of 13. We have to rationalize that denominator. So this is going to give us 2 square root 13 over 13. So sine is 2 square root 13 over 13. Cosine is x over r. So that's going to be 2 over the square root of 13. We once again rationalize that denominator to give ourselves 2 square root 13 over 13. For tangent, that's y over x. So this is going to be 2 over 3. For our next one, we have cosecant, which is the reciprocal for sine. So that's CSC, and that's going to be r over y. So that's going to leave us with the square root of 13 over 2. We don't have to do anything else with that one, so we're done. For our reciprocal for cosine, that's secant. So that's going to be r over x. R is the square root of 13. X is 3. So secant is the square root of 13 over 3. And then lastly, we have cotangent, which is x over r, and that is 3 over 2. For 19, we have p, which is 4, negative 2. So our x is 4, our y is 2. We have to find for r. So we're going to do 4 squared plus 2 squared is equal to r squared. 4 squared is 16. 2 squared is 4. If we add these, we get 20 is equal to r squared. The square root of both sides here gives us r is equal to 2 square root 5. So x is 4, y is 2, r is 2 square root 5. So sine, once again, is y over r, so that's 2 over 2 square root 5. These 2's are going to simplify to give us 1 over the square root of 5. We simplify that by multiplying top and bottom by the square root of 5. And that's going to leave us the square root of 5 over 5. Cosine is x over r, so that's going to be 4 over 2 square root 5. The 4 becomes a 2, 2 becomes a 1. We multiply top and bottom by the square root of 5. So this is going to leave us with the square root of 5 over, 2 square root 5 over 5. Tangent is going to be y over x, so it's 2 over 4, which is also 1/2. For our reciprocal of sine, that's cosecant. It's reciprocal of the 1 over square root 5, so it's just the square root of 5. We're taking the reciprocal of it. For cosine, the reciprocal is secant. So we're going to take the square root of 2 over the square root of 5, which is just the square root of 5 over 2. And then the reciprocal of tangent is cotangent. So that's going to be x over y. So that's 4 over 2, which is 2. So sine is the square root of 5 over 5. Cosine is 2 square root of 5 over 5. Tangent is 1/2. Cosecant is the square root of 5. Secant is the square root of 5 over 2. And cotangent is 2. For 20, we're skipping because our a there is 0. And whenever you have something, our x is 0. So whenever you have something that deals with that x in the denominator, it's going to be undefined. If it's in the numerator, it's just going to give you 0. Okay, so we're going to move to 21. Our a is the 3, our b is the 4, so we're going to do 3 squared plus 4 squared is equal to r squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. If we take the square root of both sides here, our r is 5. So x is 3, y is 4, r is 5. Sine is y over r, so 4 over 5. Cosine is x over r, so 3 over 5. Tangent is y over x, so 4 over 3. Cosecant is the reciprocal of 4/5, so that's 5 over 4. Secant is the reciprocal of 3/5, so that's 5 over 3. And then cotangent is the reciprocal of tangent, so that's 3 over 4. For 22, we have an a of 5, so it's going to be 5 squared plus 3 squared is equal to r squared. So 25 plus 9 is equal to r squared. That's going to give us 34 is equal to r squared. We take the square root of both sides, so r is equal to the square root of 34. So our x is 5, our y is 3, our r is the square root of 34. So sine is 3 over the square root of 34, which is going to simplify to be 3 square root 34 over 3. Cosine is 5 over the square root of 34, which simplifies to be 5 square root 34 over 34. For tangent, we have 3 over 5. For cosecant, it's going to be the square root of 34 over 3. For secant, it's going to be the square root of 34 over 5. And then for cotangent, it's 5 over 3. For 23, we have 1 and 6, so then we're going to have 1 squared plus 6 squared is equal to r squared. 1 squared is 1, 6 squared is 36. If we add those, that's 37. Take the square root of both sides. Oops. So that's going to be r is equal to the square root of 37. So our x is 1, our y is 3, our r is the square root of 37. So sine is y over r, so 6 over the square root of 37, which is going to be 6 square root 37 over 37. Cosine is x over r, so that's 1 over the square root of 37. That's going to simplify to be the square root of 37 over 37. Tangent is y over x, so that's 6 over 1, which is just 6. Cosecant, oops, not cosine, cosecant, CSC, is equal to r over y, so that's square root 37 over 6. Secant is r over x, so that's just the square root of 37, and then cotangent is x over y, so 1 over 6. For our next one, we have -6 and -5. We're going to take the positives of these. We're going to do 6 squared plus 5 squared is equal to r squared. 6 squared is 36. 5 squared is 25. If we add these up, we're going to have 11, carry the 1, and 6. 61 is equal to r squared. We take the square root of both sides, and r is equal to 61. So our x is 6, our y is 5, and our r is 61. So sine is going to be 5 over the square root of 61. Square root of 61. Square root of 61. Just doesn't disappear. Which is going to simplify to be 5 square root 61 over 61. The cosine is x over r, so 6 over the square root of 61. So that's going to be 6 square root 61 over 61. Then we have tangent, which is y over x, so that's 5 over 6. Cosecant is r over y, so the square root of 61 over 5. Secant is r over x, so that's the square root of 61 over 6. And then cotangent is going to be x over y, so 6 over 5. For our last one, we have -3, 6, so we're going to use 3 squared plus 6 squared is equal to r squared. 3 squared is 9. 6 squared is 36. If we add these two, we get 45 is equal to r squared. We take the square root of both sides. R is going to be 3 square root 5. So we have an x of 3, a y of 6, and an r of 3 square root 5. Sine is equal to y over r, so that's 6 over 3 square root 5. The 6 turns into a 2, 3 turns into a 1. We multiply top and bottom by the square root of 5. This is going to give us 2 square root 5 all over 5. Cosine, we have x over r, so that's 3 over 3 square root 5. The 3's turn into 1's. We multiply top and bottom by the square root of 5, so it's the square root of 5 over 5. Tangent is y over x, so that's 6 over 3, which is 2. Cosecant is going to be r over y, so that's 3 square root 5 over 6. The 3 is a 1, the 6 is a 2, so this is the square root of 5 over 2. For secant, we have r over x, so that's 3 square root 5 over 3. The 3's turn into 1's, so it's just the square root of 5. And lastly, cotangent is the reciprocal of the 6 over 3, so that's 3 over 6, which is 1/2.